Hello everybody. This video is going to be going over something that is in my textbook for descriptive astronomy. It's called the scale of the universe. This is chapter 1, section 1. So I'm just going to read it and then talk about what the important part is. So for most of human history, our ancestors imagined Earth to be a stationary at the center of a relatively small universe. This idea made sense at the time when understanding was built upon everyday experience. After all, we cannot feel the constant motion of Earth as it rotates on its axis and orbits the sun, and if you observe the sky, you'll see that the sun, moon, planets, and stars all appear to revolve around us each day. Nevertheless, we know that the Earth is a planet orbiting a rather average star in a rather typical galaxy in a vast universe. So that's the first paragraph. And the important thing in all of this is this sentence. After all, we cannot feel the constant motion of Earth as it rotates on its axis and orbits the sun. And if you observe, you'll see the sky, you'll see that the sun, moon, planets, and stars all appear to revolve around us each day. That's a long sentence. The important part of that is we cannot feel the constant motion of Earth as it rotates on its axis and orbits the sun. So that's not correct, because the motion of Earth is not constant in a globe cosmology. There is rotation of the axis, which is non-linear, which means you're always accelerating. You do not feel constant linear motion, but the Earth is not linear traveling. So you're turning. There's also orbit, which is turning, and you also have the sun orbiting the galaxy, which is more turning, and then you have the drift of the galaxy. That one I think might be straight, but that just makes like a vortex motion through 3D space for the way that the Earth travels. So we would and should feel constant motion and our constant drift due to this force of turning. It's feeling the catching up of momentum, trying to catch up to the new straight direction of a vector, is the force that should be applied but isn't. So yeah, the Earth is not in constant motion, it is in accelerating motion, and it should be felt. But this is also saying that that we can't feel motion, and that's honestly more confirming. Like we can't feel motion is why they have to. It's tried to be expressed as, well, it's the constant motion, but it's not constant. But if you don't have constant motion, you should feel it, but we don't feel it, because when we measure stuff, and according to our senses as well, we don't feel motion. There is none. That's how you can explain and interpret all of this scientific data. So there is nothing we can do to detect motion, but then again, also for the globe, the Earth's motion is not constant. So this text is actually incorrect, kind of starting right away, pretty much 1.1. So, or however close that is to the beginning that you want to make it. The other thing that I wanted to just get y'all's take on, what do you think about this premise? I won't. Well, okay. What do you think about this? An observation and a measurement are essentially the same thing. What are y'all thoughts on that? Okay. So yeah, basically the Earth is not constant motion. It is accelerating because of the rotation and the orbit, and then the linear vertical or vortexing drift. So it's not constant. This book is wrong. And then what are y'all's thoughts on observation and measurement are essentially the same thing? All right. Peace be with you all. Glory to God.